Hello everyone and welcome back to our lecture series. Today we're going to speak about Pascal's principle. Last time we were together we spoke about how the depth of a fluid will basically create pressure. So today we're going to see a system whereby we have two cylinders and they are connected together with a common fluid, as you can see in front of you in your screen. On top of those cylinders we have two pistons, and both of those pistons are at different areas. So now, the first thing that you have to understand is fluid is incompressible. So what does that mean? That means that the pressure is going to be the same and equal in all areas of the fluid. But because the areas are now different, that means that the force that is experienced in order to keep that pressure the same will be different, and it's going to be inversely proportional to the area. So what does Pascal's principle state? Basically states that any change in pressure applied to a completely enclosed fluid is transmitted undiminished to all parts of the fluid and the enclosing walls. So what does that mean? So that means that the pressure at two different parts of the liquid and any changes thereof must be equal, because the pressure must be transmitted undiminished. So the pressure in one column is going to be, of course, force over area, and the pressure on the other column is again going to be force over area as well. So the formula now for Pascal's principle becomes F2 divided by A2 equals F1 divided by A1. So now, let's look at the following problem. The input piston has a radius of 0.0120 meters, and the output plunger has a radius of 0.150 meters. The combined weight of the car and the plunger is 20,500 newtons. Suppose that the input piston has a negligible weight and the bottom surface of the piston and plunger are at the same level. What is the required input force? So notice here that they're giving us the radius. They're not giving us area. So what does that mean? That means we have to find what the area is. And the formula for area, as you know from math, is very easy. It's simply going to be pi r squared. So let's go to our trusty Jamboard and let's see. So we just said that the force Pascal's principle, the force 1 over area 1 equals force 2 over area 2. Okay, so now, so what did we basically say? We wanted to lift a car, okay, that is 20,500 newtons, okay, and the input plunger, of course, is going to be 0.0120. So that's the radius. So to find the area, it's going to be pi r squared. So it's going to be pi times 0.0120. And don't forget, we got to square this, okay? And the output plunger, what's going to lift the car, and of course the piston, it is going to be an area of pi r squared as well, which is going to be 0.150, and that's going to be squared as well. So we're trying to find right now the input force. So what we do is we cross multiply, and we clearly see that, you know, F1 is going to be equal to 20,500 newtons times pi times 0.0120 squared, and that's going to be divided by pi times 0.150, that's the radius for the output plunger, and that's going to be squared as well. We see that this drops out, so we see that if we multiply this, so we square the two radii, okay, and we multiply 1 by 20,500 and divide it by 0.150, it should be 131 newtons, simply using Pascal's formula. So now we go back to our presentation. And we clearly see that we plug it in, and that's 131 newtons. Thank you so much. See you in class. Bye.